Now we're going to talk about chemical methods of control. This is a challenge for me, I'd be honest, to remember all of them. Okay? So, without any further ado, when we talk about chemical methods, I'm going to try to list them, okay? And we're going to try to focus on the level of control, certain peculiarities, and what are the targets for each particular method. So first, two chemicals that I want to mention here, going to be halogens and peroxides. So we're going to start with halogens. There are currently two halogens and its derivatives that are used in microbial control. Chlorine, which is used in the formulations like bleach and chloramine. So chlorine and its derivatives are usually considered to be disinfecting. Little remark here, listen. If you use it in high enough concentration for an extended period of time, it is sterilizing. It can be sporicidal. We just don't use it because it's very, very toxic. Are we clear? Okay, now iodine in the form of betadine. Okay. Asepsis. It is convenient enough to put on the living tissue. We clear so far? That makes sense? Now, look, here's another difference. Let me illustrate some considerations. So, for instance, we used to use chlorine derivatives when I was working in research lab to clean the carts. Okay? Carts were made out of metal, metal carts. Chlorine is very corrosive, so the carts were rusting. Well, we had to switch carts. We started using plastic. But this is something that you need to consider. Can I use this chemical for my purposes, or it is going to harm whatever things I'm doing? Why we don't use iodine for disinfection of surfaces? Because it freaking stains everything, right? If we put it on the skin, eventually it'll come off. Make sense? So these are considerations that we need to think about. Am I clear? Okay. And you will notice the overall kind of idea. Better ways to control microbes are also more dangerous. Like gamma rays are awesome, but they are dangerous. Concentrated chlorine is awesome, but it's toxic. If you ever worked with mold and mildew remover, you know what I'm talking about. Now, second one here will be peroxides. So, hydrogen peroxide, okay, it's one. Solution is disinfecting. And also can be used in aseptic techniques. Okay. Now, you can use vaporized hydrogen peroxide. Vapors are sterilizing. However, I can tell you, we can sterilize. Now, why do we want vapors of hydrogen peroxide? Imagine that you need to sterilize this room. You put the machine, I saw this machine. It's a giant box, that big. You put it in the center of the room, plug it in the socket, push the button, walk out of the room, shut the door. The room is filled with hydrogen peroxide vapors. All living things will die. So if you're not walking out of the room, you're going to die too. That makes, I mean, it's really aggressive oxidant, really aggressive oxidant. That makes sense? So it works great. Now, another peroxide that is worth knowing, peracetic acid. It is sterilizing. Without naming names and disclosing the sources of information, but I know that it can be used as a spray. It is very effective, incredible irritant, very toxic. So technically, when you work with peracetic acid, you should wear a mask. Not the full gas mask, but kind of a respirator. Does that make sense? Now, why I grouped halogens and peroxides together? Because the main mode of action for them is oxidation. Okay? So they oxidize everything. So these two chemicals are oxidative. Does that make sense? Then we're going to enter kind of a large group of chemicals that can disrupt the membranes and denature proteins. So we're going to start with alcohols. I'm not going in any particular order. Alcohols. We use ethanol and isopropanol. Methanol is toxic. So they are disinfecting, strictly disinfecting. Well, we can say aseptic too, so asepsis. And they work through membrane disruption and protein denaturation. Interesting detail, not for the exam, but they are very effective against enveloped viruses, like coronaviruses, but they are absolutely useless against naked viruses. So, one of my favorite ones, norovirus, which is a two-bucket disease, a cruise ship disease, gastroenteritis, it's a naked virus. So all those hand sanitizers that are installed in the cruise ships, they're useless for that particular virus. Okay. So far,
what are the examples of alcohols that you said?
ethanol and isopropanol. Okay. That make sense? Phenols. Disinfecting. Different phenolic compounds, now used more in disinfection of built environments. Originally, the water solution of phenol, known as carbolic acid, was used as antiseptic. I'm not going to ask this on the exam, I'm going to be very straightforward here. Used as an antiseptic, okay? But it's very toxic and it's a skin irritant. So people had actually like eczema, surgeons had eczema on the skin if they used carbolic acid. So disinfecting, also membrane disruption and protein denaturation. Next one will be a group with a really tone-breaking name, Bisbiguanides. The one that really I want your attention to focus on is chlorhexidine. If you worked in a clinical setting, so you work in a clinic, you're familiar with that stuff, absolutely. So this is probably the best disinfecting chemical agent that we have. Chlorhexidine is okay. Disinfecting, sure, but nobody's going to waste chlorhexidine for disinfection. So we're going to put it as aseptic. I'm going to put disinfecting in the parentheses. Okay? Extreme, very safe, very low toxicity. Again, membrane disruption and protein denaturation. Now, I want to go back for a second to phenolics, okay, these ones. So in phenols, there was one substance developed called triclosan. I don't know if you've heard about it or not. Triclosan, no? Okay. It used to be a component of antibacterial soap. And recently, relatively recently, a few years ago, FDA announced that it shouldn't be added to antibacterial soap for several. So they compared basically antibacterial soap and the regular soap and found that there is no difference between the two in terms of antimicrobial effects when you wash your hands. That makes sense? So what happened? Triclosan was pretty effective in the lab, but when it was in the soap, the concentration was really small. Okay? So it wasn't particularly effective in the first place. Second, when people started to use antibacterial soap, we started to dump a whole bunch of triclosan into the environment. So bacteria developed resistance. Are you following me? There were claims that triclosan was toxic for humans, which, if you think about it, it's got to be true, because everything is toxic for humans. It all depends on the dose. But in the amounts that it was used in the soap, triclosan was never shown to have any toxicity for humans. So two main reasons for triclosan to be withdrawn was lack of effectiveness and development of resistance. Well, not lack of effectiveness, but low effectiveness and development of resistance. We're clear? So now we're going to move to the surfactants. Surfactants, or surface active compounds, can be divided into two categories. We're going to start with cationic surfactants. Okay? So these are positively charged, usually quaternary ammonia. Now, what is quaternary ammonia? I know this is not a chemistry class. I use this for illustration purposes. Basically, I want you to know this term, but I don't really care if you remember the formula. So general formula for quaternary ammonia will be nitrogen with 4 substitutes. Does that make sense? You see that? So this nitrogen will carry the positive charge. Are you with me here? Good? So, usually 1 or 2 of these R's is a pretty long organic chain, fatty chain. Are you following me so far? So here's the trick, listen. Remember we talked about the structure of microbial plasma membrane, cell membrane? Cell membrane is negatively charged. Are you following? Positively charged cations readily bind to negatively charged membrane. Long fatty chain gets stuck into the membrane, disrupting its structure. Okay? So membrane disruption. They are weak disinfectants. Well, I shouldn't say weak. Let's put it just disinfectants. It all depends on concentration. So, which ones? Most household cleaning items like Lysol, those are quaternary ammonia. Does that make sense? And what about anionic? Negatively charged, usually sulfates. So you're going to have something like long fatty acid chain, sulfur, sulfate group with a negative charge. So basically soaps, just sanitization or degermation. So contrary to the popular belief, soaps by themselves are not disinfecting. All they do is they help to remove microorganisms from your skin. They basically help you to exfoliate the skin, help to get the grease out. So far we good? Clear? Okay. I think we have a couple more. My memory serves me well. So we've got heavy metals and alkylating agents. Now, heavy metals are kind of a weird bunch because look at all the previous ones. All the previous ones we could spray on the surface, right? Heavy metals, we can't really do that. We have to coat the surface before, which makes it an advantage and a disadvantage. Obvious disadvantage, you can't just apply it, at liberty, but it will stay on the surface as long as you use that surface. So if I would coat these faucets with copper, they would be coated with copper as long as I'm using them. Copper is not going anywhere, it's not drying out, it's not being washed off, something like that. Does that make sense? So what is the level of control? It's considered to be disinfecting. They substantially, heavy metals like copper and zinc and gold and silver substantially reduce the microbial contamination of the surfaces via enzyme inhibition. The term that you need to know is that heavy metals are oligodynamic, which means they work in a really small, really minute concentrations. Does that make sense? We good? And the illustration of this, if you look at the vessels that were used to store wine and beer and milk in old times, people who were rich used silver. People who were poor used copper, bronze, stuff like that. Does that make sense? So what happens there? Small amount of metal goes into the solution and provides those inhibitory properties. So very, very small amount. We good so far? So very last group here will be alkylating agents. If they are used properly, they modify DNA and proteins, essentially resulting in denaturation. And that makes them, again, if used properly, they are sterilizing agents. Are we clear so far? Okay. So two groups that you need to know the separations of gases, which are ethylene and propylene oxide, and formaldehyde. For instance, so little illustration, which comes from my experience. I worked in BSL-3. When you walk in by BSL-3, if you carry something with you, like not under the costume, not under the suit, but like you walk in and you have a pen in your hand when you walk in, this pen stays in the facility. Does that make sense? Like if you bring computer, it will stay in the facility because it's immediately considered to be contaminated. How do you clean? Once a year you do decon of the facility. How do you do that? You fill the facility with formaldehyde. I mean, nobody works there, obviously. You just fill it through the HVAC system, leave it for a few days, turn on HVAC, and it all gets sucked out into the environment. That makes sense? For those few days, everything, like all nooks and crevices are penetrated, everything is being killed. Does that make sense? Now, there are liquid agents. So this is going to be beta-propionolactone. Glutaraldehyde and phthalaldehyde. Now, these are usually used to preserve biological specimens or that from rotting and, you know. Does it make sense so far? Good?
What would they use that for? They prevent what from rotting?
Prevent what?
The liquids, what would they use those for?
Just easy to dump the corpse in. You know, like, because if you need to preserve, when I say, like, you take a dead body, put it in glutaraldehyde or beta-propionolactone or phthalaldehyde, and it will preserve those tissues from rotting. Does that make sense? Good? You okay?
Yeah.
Okay. Yeah, I think that's it. Oh, yeah. Kind of questions. Again, if I ask you which of the following methods you would use to sterilize a plastic, and I give you options, and you look at them and you think, there is no gamma ray, so I've got to use probably some chemical, and sterilization, what can I use? Peroxide, that would work, yes. Not used often. Alkylating agents are a little better because peroxides are very, for instance, aggressive to the surfaces, to the metals. Does that make sense? Alkylating agents are only toxic to humans. So basically, if you stick some metal instruments into the ethylene oxide gas, they're going to be sterile and that's it. That makes sense? Stuff like that. Usually it's not an issue. So know the mechanisms, know why, why these ones, quaternary ammonia, are more effective. We discussed that. Positively charged, more efficiently bind to membrane. These negatively charged, they get repelled by the membranes. They're not really destroying the membranes. Does it make sense? Good?